Hello YouTube, welcome to 2016. So in 2016, well, this year now, we're going to be covering a whole bunch of new topics as promised in Christmas 2015. But for today, I thought I'd do a bit of a multi-part episode, sort of like a bumper edition, where we're going to do some repairs of some various electronics equipment, starting with this media player over here first. We're then also going to take a look at data recovery of a USB drive that's been broken in half, and various other interesting projects, to say the least. So guys, keep watching the episode and don't forget to subscribe. Let's get into it. Right, now onto the repair of this media tank. First thing I notice is we have a Western Digital 1TB hard drive over here. The hard drive, I'm just looking for a date or something on it. Just to try and get an idea of how old this drive will be. We've got all the information except for a date of manufacture, which I'm used to seeing on the Seagate. Maybe I'm just not looking in the right place, I don't know, but I'm not seeing a... Wait, there we go. This is a 17 June 2010 hard drive. So this hard drive was manufactured in 2010, making it 6 years old. Well, 5.5 years old, 6 years old. So in my opinion, if this hard drive has failed, then that could by all means be the reason for this device coming in here for repair. Now I've asked the customer to bring in the remote, and then we can give a test run of the device and see if it is functioning or not, what the problems could be. I have done some scanning on the hard drive and found that the hard drive seems to be okay for all intents and purposes, but worst case scenario, what we might do is just swap this hard drive out for a new device, for a new hard drive, and try and move the information from this drive onto the new drive. But we'll see how that works out, so let's wait and see for the remote to come in a bit later on this morning, and we'll continue then. Okay, so what we've managed to ascertain about this media tank is that it does power up. The hard drive does spin up. We are getting screen display of the tank. Everything seems to be functioning fine. So my suggestion now moving forward is to take this hard drive out, plug it into the computer, and let the computer do a thorough hard drive test to check if there are any errors on the hard drive itself. And if that's the case, maybe swap it out. But also just to clean up all the connectors inside the like for instance the hard drive connector over here, clean it up, because there seems to be quite a bit of dust accumulated inside this device. So maybe a bit of a cleanup might solve any sort of strange issues. And while I'm at it, I'll also do some voltage checks just to make sure that everything is fluid. Now I don't have their power block, which worries me a little bit, because I'm running off my bench power supply, which I know has a good known signal. Their power supply may be faulty, which may also be causing intermittent issues with the device's functionality. But we'll test that, and we'll check that out in due course. So, in order to check properly, we just need to try and ascertain if the voltage coming in is actually sufficient to properly power this device. So 11.83 in, which doesn't make too much sense to me, because from what I can see, we've got 12.05 volts. When we power it up, there might be a bit of a drop in power, which is fine. And we can check. So we're getting 11.8 volts. Then on the power bus over here, we've got 5,151 volts, which is sufficient. So the regulator is doing its work. .73 volts. Well, you know what, it might be alright. It just seems a bit low, being a quarter of a volt down. So I'm not going to worry too much about that just yet. We'll know if it's a problem a bit later down the line. The 5-volt bus definitely seems fine. Let's just check here. Should have 5 volts there, perfectly 5 volts. What else do we have over here? Another 5-volt rail should be here. 5,163 volts. So that's fine. 5 volts, that's fine. .3 volts on that point, fine. 3.3. 5 volts. So yeah, you know what? It's not too bad. It seems to be alright. If I was working on the circuitry, I wouldn't be too happy with it, but you know what? It'll get the job done, which is all that really matters. So I think that's fine. We'll keep the voltages as they are. We won't toy around with anything over there because I think it should be alright. Okay, so what should have been pretty obvious to me from the beginning was that the device was pulling the power supply down. After some checking, I did find a couple of electrolytic capacitors which had gone bad. They have been replaced in the media tank. I didn't record a video of the actual replacement of those capacitors because I thought by now most people would know how to do that, but I will be doing a soldering tutorial in due course. I'm just waiting for some of my new soldering equipment to arrive. But let's carry on with this edition. Like I said, this is a bit of a bumper edition because we're going to be covering a lot more information than just the one device. Right now we're going to take a look at resoldering of a USB Wi-Fi adapter, as well as some microscope views of a USB thumb drive which has been snapped in half. I've been tasked with data recovery of the data that's on the flash drive. It sounds like a simple enough task, but bearing in mind some of the track work on these devices cannot even be seen without a microscope. So this will give you a good idea of the intricacies of repair work, etc. when it comes to data recovery of USB flash devices. So let's get straight into that. Happy 2016 from everyone here at the Evian Labs. Have a great year everybody, and don't forget to subscribe and watch for those tutorials. No, this isn't a beer ad. Okay, so if you have a look here at this USB drive, you can distinctly see where it's been broken in half. The tracks are completely destroyed. Here we've got our 5-volt rail, and if you look closely over here, you can see the actual 5-volt rail track is completely damaged and broken. In fact, it's actually loose. We also have a brake. This brake, by the way, does go right through the board to both sides. Completely disconnecting the USB socket from the, or should I say the USB male jack from the ICs on the USB drive. This was brought in for a basic repair so that people could recover the data on it. Now, there's multiple ways we can repair this sort of work, but what I'm going to do now is I'm going to rerun the tracks on this specific unit over here, and then see if we can get it back up and functioning again so that the customer can recover the data from their drive. And let's just hope this works out quite nicely. Right, so what we're doing here is we're just basically going to replace the positive power rail of this USB thumb drive, as well as do some micro soldering to get some power and USB connectivity back into this device. It's never an easy task to do, but it's definitely a doable exercise. Yeah, it's going to take a bit of time and a bit of patience because this is very fine work. What you have to kind of do is trace it through, see where it's meant to be, make sure all the wires are still connected, and then rebuild the tracks using little pieces of wire, which you'll see us doing over the course of this video. Now, where this can get tricky is sometimes there are underlying connections and stuff that you have to be aware of, so you don't want to create any shorts. And also, you cannot use a standard size soldering iron to do this sort of soldering work. You really need to be able to do this with a micro pencil or something similar. I've seen it done with hot air, but hot air station is really a bit of a silly exercise for this sort of thing. So where it really comes into its own is board repair, pretty much laptop board repair, cell phone board repair, pretty much anything like that. The micro soldering is a very important exercise when it comes to this sort of thing. So as you can see, as we go through this, you'll see how the soldering is done, and you'll be able to put it together, how you can do track repairs, and then how we can do a data recovery of the information based on this USB thumb drive. It's tricky. It takes a bit of practice, but once you get the hang of it, it's really not too difficult. And bearing in mind, I'm here soldering on a piece of resistor lead, and you can see how thick this piece of resistor lead is in comparison to the components and the legs of the ICs that we're working around. So care has to be taken so that you don't create any shorts or create more damage than what was originally done. Now, somebody's already had a go at this USB, and in so doing, they've actually made it a lot worse than it would have been if they just brought it straight through to me for recovery. So it's going to be an interesting exercise seeing if we can get this thing soldered up and working or functioning as it should be. But we'll see definitely how it goes from there onwards. So as can be seen on this video over here, you can see basically how the soldering goes to replace damaged tracks to try and enable you to get the data off the USB drive. Just to let you guys know, we were successful in recreating the connections between the USB socket and the USB NAND device or actual flash device based on the chip. And the data recovery should not be too much of a problem. We should be able to get all the information back. It's busy recovering at the moment, and hopefully the client will be happy with that. Now, let's do a little bit of a break from the repairs and go into a review of a very basic little meter. This is a review of this little guy over here. This is a Toptronic T835 digital multimeter. It is an analog ranging meter. It does do quite a nice job of basic measurements, etc. It was sold as an electrical meter and costs less than 200 bucks here in South Africa, 200 Rand. So it's definitely worth a look-see for those looking for a budget meter. So let's take a look at the review of this little multimeter, and your comments are welcome. Right, now getting straight into the review of this Toptronic T835 digital multimeter. This is a basic electronics electrical test meter. The meter does volts DC, volts AC. It'll do amps, AC and DC down to 200 milliamps. It can do degrees Celsius, degrees Fahrenheit, diode, continuity, resistance test. So for all intents and purposes, it's a really simple meter with a nice display. It has a rather nice blue, well, sort of white backlight display. So even if you are to switch off the bench lighting, you can still see a nice display over there. The continuity buzzer does the job. It's not latching, you can hear a bit of crackling there, but for all intents and purposes it's loud, it's clear, it does the job quite nicely. I've done a few volts DC and AC measurements with this one. For example, if we go onto our reference supply over here, that's a 12 volt supply, so you can see it's reading 12.01, that's pretty accurate. This is a 5 volt supply, 5.03, and at the moment I've got the variable sitting at 3.3, so 3.32 volts. For all intents and purposes, it's good enough for most of that sort of stuff. As far as the build of this meter goes, it's actually not too bad for a cheap meter. I'm talking a sub 200 Rand multimeter. It's actually not bad at all if you consider that. The leads are very cheap, plastic. The leads do say 1000 volts, double insulated, but that's it. There's no CAT ratings on them or anything, and this is a CAT 3 600 volt meter. So that leaves a little bit in question over there. So let's see what else this meter has to offer. Hey everybody, welcome to this first review of the Toptronic T835 digital multimeter. What does this meter have to offer those in the electronics or electrical field? Well, let's take a look. First, let's discuss what this meter has to offer. It is a manual ranging digital multimeter which can do volts DC from 200 millivolts, well, probably from 1 millivolt resolution. Let's have a look at that. That's 200 millivolts, so it'll do down to, I think, 100 microvolts. Anyway, then you got your 2 volts, 20 volts, 200, 500 volts. Then on the AC side, you can do 200 volts, 500 volts AC, so not good for very small AC measurements, but good enough for most sort of testing. Amps DC, it'll do 2 milliamps, 20 milliamps, 200 milliamps, and 10 amps. Now, I'm not seeing an AC amp scale over here, so I'm assuming that it can't do AC amps. Then you've got degrees Celsius, degrees Fahrenheit, diode and continuity, and you got from 200 ohms with a resolution of, let's just see, of 0.1 of an ohm, 2K, 20K, 200K, 20 meg, up to 20 mega ohms, so that's not too bad. And then the one thing that this meter does have is a very nice white backlight. If we power off the bench lighting over here, you can see still quite clearly the difference with that backlight. And yeah, that's the basics of the meter. Let's just have a look at the continuity tester. Now, I know it's not latching. I mean, this is a sub 200 Rand multimeter, but it's nice, clear, it's loud, it gets the point across, so yeah, it does the job. The build of this meter is not too bad. It is in a removable sort of thin housing. It has quite a tight, wide tilting bail, so the meter is not going to easily fall over unless you pretty much whack it over. It uses a single 9-volt battery, which is changeable from this little cover over here. As far as the usability of the meter, it is very usable. I've used it for a couple of days now on a second bench as a volts test meter, etc., and it gets the job done. So if you're looking for a really cheap sub 200 Rand meter that's going to get the job done for you, then this might be the meter for you. The meter is rated Cat 3 600 volts. Whether that's true or not, I don't really know, but we're going to take a look at the inside and see what it's all about. Okay, now the removal of the sheath is pretty simple. Pop it open like that. Now if we look over here, I don't see any other screws in this meter except for the one at the top over here, so let's get that out. Take that screw out. It does fall out, so be careful. As you can see, just the usual cheap battery with battery clip. And here we can see 2 more screws to get inside this meter. So let's pop that open. We've got plastic self-tappers over here, nothing expensive. And we get inside this meter. And there we have it. Now, bearing in mind, a meter like this is never a very complicated affair. They kind of keep it as simple as possible. Let's see how close we can get to this. Right. Very, very, very cheap connections to the board. Personally, I don't think this meter is going to meter. I mean, it's got one little MOV over here, but nothing else in the way of protection, and one little standard glass blower fuse. We've got the multimeter chip over here, a couple of resistors, voltage dividers, some maybe calibration points. There's absolutely nothing too fancy on this meter. There's actually, here you've got your little current shunt. Yeah, quite interesting for a simple multimeter. Now, if you have a look over here, you've got your little red and black wire, which is for your backlight, obviously. Construction of this isn't designed to be repaired, it's designed to be thrown away, hence the price of 159 Rand. Yeah, but I must say, having said that, the SMD soldering work inside here is actually pretty decent. I'm seeing no botch jobs or anything like that. Most of the electronics is SMD. It's not bad for the money, guys. Really not bad. Like I say, not a terribly expensive meter, but definitely usable. Wow, not bad at all. So after all is said and done, can I recommend this meter for those in the electronics or electrical field? Maybe as a basic electronics multimeter, yes. For somebody who's just starting out or a hobbyist, it will probably do the job quite nicely for you. But for a professional electronics technician or electrician, no, I would not recommend this meter for use in the industrial fields or in the electrical trade. Thanks for watching, guys, and until next time, take care. Hey YouTube. So what we're doing over here now is the little proto board that I built. I've put some standoffs on it. I have a knob for it, etc. I've mounted the LM317 on a nice large heatsink, which should give it more than sufficient cooling. I've done a bit of a cutout on the plastic chassis over there. Now all I've got to do is drill the holes and of course mount our volt ammeter. Now this volt ammeter has been fixed. These things are quite synonymous with not contacting properly. So what I basically ended up having to do here, let's just see if it will focus. And we're not getting a focus. So let's go manual focus. Anyway, this chip over here, I had to pretty much load some flux in and just basically drag solder it back down to make sure it contacted, and now we don't have any intermittency issues with this. So pretty much everything is back up and operational. Let's just let the focus kick back in. So yeah, this is going to get mounted inside the box over here. This meter will get mounted there. A set of outputs for the variable, and of course a 5 and 12 volts set of outputs, because what I'm doing here from the modular power supply is this will come out from the modular power supply on this bench, and then this will be wired into this to give this bench a variable power supply. Bearing in mind with the LM317, your maximum is probably going to be around about an amp for a 9 volt circuit, which is sufficient for what I'm basically looking at. For any sort of large voltage, or should I say large power circuits, will probably run off the 12 or 5 volt rails, which on this power supply are in excess of 30 amps, so that's no problem at all. Bearing in mind also, this power supply doesn't have any current limiting. This is just a basic idea to show you guys what can be done with PC power supplies and additional build. Let's carry on with the drilling now. And here we have the power supply on test at the moment. We've got a 5, 12 and variable outputs, basically being able to vary the DC voltage to pretty much anything that you want between 0 and 12 volts. And yeah, that's pretty much it.